a wire of length 28 meters. Okay, so what do we do with that? It's cut into two pieces. Okay, one of the pieces is to be made into a square, right, and the other into a circle. What should be the length of the two pieces so that the combined area of the square and the circle is minimum, right? So this is your optimization question. Now I'm going to take the length as 2 pi x, and or you can take it as 2 pi r and 4a, or if you guys want to go with x itself, we can do this as well. But why do you think I'm taking this set of values? You can go with x and y itself, but I'm going with this. Making the circle and the square respectively. Now from this we can tell that 2 pi x plus 4 pi y is equal to 28. I hope you guys got the funda. I'm relating 2 pi x to your circle and square to 4y because the perimeter of these two structures are so. We'll call this as 1, we'll need it later. Now what will be the total area? Total area will be, I'm going to represent it as say t of x comma y. It would be basically area of the square plus area of the circle. So you guys know my funda. I'm going to take the expression in terms of x and y and then substitute things later when we have to actually find the value of x. Okay, that is something that I feel is convenient. Now the working. So very first thing is we need to find the expressions. So perimeter of the square is given by 4a. So 4y is equal to 4a and we have y is equal to a, right? Simple thing. And so the area of the square will be y square. Next, we have the perimeter of the circle, which is given by 2 pi r, not 4. And so we have this to be 2 pi y is equal to 2 pi r, or 2 pi x, my bad. 2 pi r, so x is equal to r. Agree? And finally, we have the area of the circle to be pi x square. And from this we can infer that t of x comma y is equal to pi x square plus y square. So if you think of it, this is your constraint, and if you take this, that's your optimization expression. Right guys? Now how do we go about doing this? Same funda as before. What is that we have to do? Yes, we have to figure out the critical point of t of x comma y. So how do you do that? We need to differentiate t of x comma y with respect to x, as x and y are related as per the first equation. So we can differentiate this manner. So I hope you guys understand the entire math. So this would be 2 pi x plus 2y and y prime. This is as per your chain rule. Now I need to re-express all of this so that I can get a single expression or single variable expression. How will I do that? By substituting for y and y prime. For y, we have the equation 1. Where will you get y prime from? Y prime from. So we will get the y prime from first equation itself. So what will we do? We're going to differentiate 1 with respect to x, and so that would be 2 pi into 1 plus 4 into 1 into y prime is equal to 0, right? So we have 2 pi x plus 4y is equal to 28. So this is a constant, so this will be 0. Differentiation of this is 4 into 1 into y prime. Again, chain rule. And this is 2 pi into 1. And so we have y prime is equal to minus pi by 2. So we're going to substitute, say, y and y prime, and we'll call this as a. So we'll end up with t of x. So now we have the entire expression in terms of x, right? So let me do that. Where is it? Okay, we have this to be 2 pi x. Then we have minus pi by 2 into 2, and y would be, so that is 28 minus 2 pi x divided by 4. Okay, I looked at this equation and I was able to do it. And this is y prime. I've substituted before itself. So this and this will get cancelled. Right. And we'll find the 0, 2. So we have the zeros of t prime of x. Okay. So see, as you can see, now we can simplify and figure out. Yeah, figure out the value of x. That's it. So this is how you work it out. So basically a bit of rearrangement. So let me take 2 pi x on the right hand side itself. Let me keep that. When I multiply this, I'll get plus pi by 4. Actually, this will be 2 into x. And if I transpose this onto the left hand side, this will be 28, will be 14 by, 7 pi. Okay, I hope that made sense. 7 pi, yeah. Now, if I rearrange all of this, what will I get? I think I made a mistake. Let me just pause and have a look. Okay, you know what? I generally don't do this. I would like to eliminate, first thing is there's pi that is common, and I'm going to multiply this entire thing with 4 to make it, or let me do that in the next step. So this would be 0 is equal to 2x minus, if I take 2 common, 2 by 4, this would be 14 minus pi x. You know what? This is a lot simpler, is it not? Okay, now it makes sense to me. Now I can not differentiate, sorry. I can multiply this throughout with 2, and so we have 0 is equal to 4x minus 14 plus pi x, right? Again, this 2 and this 2 will get cancelled, and 2 into 2 is 4, 0 into 2 is 0. So basically x is equal to 14 divided by 4 plus pi. So many, I think the answer is meters also. Anyways, so we'll see the answer later. Now, is this the point of minimum? Because we're looking at a point of minimum. So we need to differentiate. We'll call this as p, differentiate p with respect to x. Or differentiating t prime of x with respect to x. So we end up with t prime of t double prime of x to be equal to simpler form is over here itself. Anyways, that I'll use minus. So if I multiply this, pi minus pi by 4. Okay, you know what? First, let me copy this off. So this would be 2 pi x minus pi by 4 into 28. So that would be, okay, so 28, 7 4s are plus, and then again we have 2 pi square x. Pi square x, right? Yeah. 7 4s are, then pi, so on and so forth. Okay. So we have this. This is 2 pi. This is 0. And this is 2 pi square. So this is clearly greater than 0, implying that t of whatever that value is, the above value is point of minimum. Local minima basically, is it not? Because there is no other critical point, so we have this following thing. If I substitute, therefore, let me do this. T double prime of 14 by 4 plus pi and all of that will be a value which is greater than 0 because there is no x itself. So whatever I substitute, it's a constant function. So therefore, the above point is a point of minimum, right? So with this understanding, all I have to do is find the value of y. That's it. Okay, guys. So what did we do? We found the expression, very first thing. We differentiated that with respect to x. And now I substitute and get only in terms of x. The expression over here, it's only in terms of x. And then I find the critical point. So this is your critical point. And once I have that, I need to check if the point is, minimum or maximum. Since it's greater than 0, we know that is minimum, right? I hope you guys remember this. So local minimum, if we have it to be greater than 0. Okay. And now, therefore, solving for y by substituting x in 1. So what do we have? 2 pi x. So x is 14 divided by 4 plus pi plus 4y is equal to 28. I hope I'm right about that. A bit of rearrangement, and we have 28 minus 28 pi divided by 4 plus pi. LCM and all of that. So 28 into 4 would be 28 into 4, 120 minus 6, 8, 112, 112, and plus 28 pi minus 28 pi. This entire expression divided with 4 plus pi. This and this will get cancelled, and 112 divided by 4 plus pi. Right, guys, and finally we can tell the lengths, or we'll just tell lengths are. So first one is 2 pi x. Remember, it's not just x, it's 2 pi x. So x would be that. So this is 28 pi divided by 4 plus pi. So SI unit is something that I have to check. And we have 4y, that is 112 divided by 4 plus pi. Okay, so I'm missing the unit. So that is in meters, so that those will be in meters. So this would be your answer. Okay, so I think I feel like revising this again. I'll do that. So first unique thing that I did was I took up 2 pi x plus 4y. The reason being the perimeters of a square is, well, 4a, and the perimeter of a circle is 2 pi r. So this makes it a bit convenient. And so we have a clear-cut expression for area of circle and area of the square. And now total area will be dependent on the expression of pi x squared plus y square. This I differentiate. This is the thing that I think I differ from most of the reference material out there and your traditional class teaching as well, I guess. So I use chain rule and product rule and all of that wherever it's required. And finally I substitute y and y prime, so as to express your total area, the derivative of that, only in terms of x. And I'll solve this and I'll figure out the value of x. And yes, we need to differentiate. Okay, so we need to differentiate this again, right? So as to show that this is the point of minimum. And once we have that, we need to solve for x and y. See, point is this will be so, whatever they ask the question in, it would be so. But yeah, if by chance they want to trick you guys, if you get less than 0, don't get confused. Just have to tell that there's no point of minimum. So the above question is not, it cannot be solved. Yeah. If by chance if you had less than 0. Whatever they're talking about, if you have an opposite answer over here, then it is so. And then we solve for x and y, and remember we have 2 pi x and 4y are your lengths, and the units, they will carry half mark. So I would like you guys to not to miss the system with which we have solved. So well organized, well structured, it means the same actually, well written. So see to that you guys also get into such habits.